Woot woot. All right. For those of you that struggled last week, it was a tough week. There was no question about it. I was very lenient on the graphs in your assessment last week. I was much more lenient than I usually am. But this week, I think you're going to find it to be way easier. We're going to be we're getting away from trigonometry, and we're going to go into exponents, exponential decay and exponential growth. And I think most people are going to find it to be a whole lot easier. In this week's assessment, way easier. You will need a calculator. There's no question about it. Some of the answers tonight, you're going to be taking like, 500 raised to the 30th power. You don't want to do that by hand. So this week, calculator is perfectly fine. That's not a problem. All right. So what are we going to do this week? We're going to graph exponential functions. So number one, you have to be able to graph an exponential function this week. You will also have to be able to write an equation for an exponential function. And you will also have to be able to write an exponential equation and solve a problem. So there's really 4 things that you have to be able to do this week. So the first thing we're going to talk about is we're going to talk about graphing exponential functions. Okay, and then we'll talk about writing an exponential function. An exponential function is any function that has a variable in the exponent. That's what makes it an exponential function. So if I gave you y is equal to x squared, is that an exponential function? No. It does not have, it's a quadratic. Very good. It does not have an exponent. So if I gave you something like y is equal to 2 to the x, there's the key. Exponential function has a variable as an exponent. So I know that the graph is going to look something like this. It's going to be exponential growth, so it goes up, or it could be exponential decay. It could come down. Boom. That are the 2 different types of functions that we're going to be dealing, or the 2 types of graphs that we're going to be dealing with this week. An exponential function is written out this way. Exponent up there. How do you graph them? Well, I'm just going to have you guys do data tables. Make a table out. Give me a couple points and graph it. That's it. That's all you're doing. Now, it's pretty easy to make a graph. So for example, if I gave you this problem right here, y is equal to 2 to the x, and I asked you to graph this thing. Well, once you get good at these things, you're going to know, okay, this is my base. My base is greater than 1. I know the graph is going to go this way. What are some important things? First thing is, where does it cross the y-axis? This is the y-axis. Where does it cross? Well, if you put 0 in for x, it tells you where it crosses. What is 2 to the 0 power? 1. Anything raised to the 0 power is 1. So I know it crosses at 1. Awesome. And then just put a couple other points in there. Let's say I said, okay, what is 2 to the negative 1/2? Well, remember, exponents, if you have a negative exponent, it just rewrites it as 1 over 2 to the first. So 2 to the negative 1 is really 1/2. 2 to the negative second is really 1 over 2 squared, which is 1/4. So what we're going to do is we're just going to plot a few points. Boom, 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 and then you're going to graph it out. Now, in this problem, what is a domain? Domain means all of the values that you can plug in for x. What's my domain? Can anybody tell me? All real numbers. Yep. You can put anything in there. You can put negatives in here. You can put positives, anything. So domain, for an exponential function, the domain is always going to be all real numbers. Now, the range, you usually have to look at the graph, okay? So the range is all of the values that the graph graphs on the y-axis. And usually it's just going to be all values greater than y is greater than 0. Now, it's not always the case, because sometimes your graph will be up here. So it'll end up being y is greater than 2 or something like that. But usually it's going to be y is greater than 0. It's going to be everything above the x-axis for your graph. But how do we graph these? We're just going to plug in some points, and we're going to graph those points. That's it. So if I gave you this problem, y is equal to 1/2 x. Again, I'm just going to ask you to plug in some points. If I put in -2 there, well, guess what? 1/2 to the negative second power is really the same thing as 2 to the second power, which is 4. So -2,4 is a point on the graph. So I go -2, go up to 4. Then I might put -1 in there. So if I put -1 in here, that's going to be 1/2 to the -1, which is 2 to the first, which is 2. So -1, 2. Plot that point. Where does it cross the y-axis? And that is going to be asked all the time this week. Well, it crosses at 1. So 0, 1 is a point on the graph. What if I put in 1? Well, 1/2 to the first power is 1/2. So you just fill in your tables, and you plot some points, and you graph it out. Now, would I accept this as an answer? No way. It crosses the x-axis, and these graphs won't ever do that. They'll get really close to the x-axis, but it's never going to cross it, because it doesn't matter what number you put in here. Put in 10, 1/2 to the 10th power. Well, that's going to be, well, I don't know what it's going to be, but it's going to be like, 1 over, I don't know what that's going to end up being, like 1020, but it's not going to be below 0. It's always going to be above the x-axis. Okay? So when you're asked to graph this week, all you're going to do is you're going to plot some points. Oops. I don't want to do that, because these are just examples. Okay, so let's say I asked you to graph this thing. And this is a very good problem to ask you to graph. So if I was going to ask you to graph it, and this week I give you the tables that I want you to fill in, x and y. So let's say I said -1, 0, 1, 2, 3. Somebody please tell me, what is the value at -1? Yeah, yes, just make just x equals 0. That's always, anytime you want to find out where it crosses the y-axis, not the x-axis, where it crosses the y-axis, just plug x equals 0 in. Yep. Okay, so Samantha says that if I put -1 in here, so this is going to be 5 times 2 to the -1. The -1 only goes to the 2, so that's going to be 5 times 1/2, which is 5/2. Where does it cross the y-axis? Well, I'm going to put 0 in. Crosses at 5, right? Good. Everybody thinks that it always crosses at 1. It does not. If you put 0 in here, 2 to the 0 is 1, so then I end up with 5 times 1, which is 5. What happens if I plug 1 in there? What do I get? 10. I agree. What if I put 2 in there? 20. Good. So that's exactly what I want to see you doing tonight. So at -1, I'm at 5.5. Well, 5.5 is like 2.5, right? Now I could have put -2 in there, and you'll see that it'll just keeps going down like this. So it's going to look something like this. Then it's going to cross at 5. So my graph is going to look something like this. And it's really going to shoot up really fast. Yep, and your graphs don't have to be perfect, but I do want to see those points on there, right? I want to see at least 5 points on your graph tonight. So if you have 5 points, I'm good with it. Now, did I know that this was going to be an exponential growth graph? Yes. How did I know it? The number that's attached to the variable, if it's bigger than 1, it's exponential growth. If it's less than 1, so if I gave you this problem, 5 times 1/2 to the x power, that's going to come down like this. It's going to be exponential decay. This number tells us if it's exponential growth or decay. Watch the video. Yep, I did go through it. Okay, so now, how do you write an equation? Okay, so let's go back here for a second. Where does this graph cross the x or the y-axis? 5. I knew that before I even graphed it out. Why did I know that? Because this number right here tells me that. This number is where it starts, and that means at 0. And then I have my base to my exponent. And what does my base tell me? My base tells me if it's going to be exponential growth. So it's going to tell me if it's growth or decay. So this number in front tells us where it's going to start or where it's going to cross the x-axis. This number tells me if it's exponential growth or decay. So now, if I want to write an equation, there's only 2 pieces of information I need in order to write an equation of an exponential function. I need the b value, okay, because remember, it's written out this way. Y is equal to b times, I won't use b here. Y is equal to, okay, I'll use b, times r to the x. Okay, so b is the number where it crosses the x-axis. So in this problem, what is my b value? Looks like 2, doesn't it? So b is equal to 2. What is my ratio? That is this number, the ratio. And how do you find that? Yeah, you can take any 2 numbers that are next to each other. Okay, so this one is, it's up 18, and this one is up 6. So 18 over 6. Or I could take 6 and 2. What is 18 over 6? 3. What is 6 over 2? 3. That's my ratio. That's how fast it's going up. So now, that's how easy it is to write an equation. Y is equal to 2 times 3 to the x. Boom, done. Yeah, that's it. I only need, yep, it has to only 1 unit apart, correct. So let's do number 3 before we go to number 2, because number 2 is going to mess some people's heads up. Okay. Number 3, what is my b value? 0.5, or let's say 1/2. What is my r value? Oh, 4. Okay, so I look here. This looks like it's at 8. This looks like it's at 2. This looks like it's at 1/2. So the ratio, 8 divided by 2 is 4. 2 divided by 1/2 is 4. The ratio has to be the same, or else it's really messed up. So now I have where it crosses the y-axis, my ratio, easy to write an equation. Y is equal to 1/2 times 4 to the x power. Done. Over and out. Love it. I mean, when you write a linear equation, or if you write an exponent or a quadratic equation, it takes a whole lot more than this, doesn't it? Exponential equations are so easy to write. Now, this is an exponential decay problem, right? Okay, so keep that in mind. What do I know the r value has to be? Okay, what does the r value have to be for number 2? Less than, well, not less than 0, less than 1 and greater than 0. Okay, it has to be less than 1, greater than 0. So now, again, my b value, I always go to that. So my b value is, okay, what's my b value? 2. Okay, now my r value, again, you still have to take these values here, but this time we go the opposite direction. We go 2 over 4 or 4 over 8. That's the way we're going to come up with that. So it looks like it's 1/2, right? So my r value is 1/2, and my equation would be y is equal to 2 times 1/2 to the x power. Now, could you check yourself? Absolutely. Go to Desmos, plug these equations in. You will see that they do work. Samantha, that is a good way of looking at it. Yeah. Yep. Okay, so that is how you write. So we've learned how to, or we reviewed how to graph exponentials. We learned how to, or we reviewed how to graph exponential, or write an equation for an exponential. And then the last thing for this week, oops, let's try this problem. I think this is problem number 1 on our practice this week. which graphs could we cross off right away? Because we know what type of equation this is, right? I mean, there's only one that even comes close to what we need. Okay, 3 times 1. D is the only one that could be our grade, right? Because it's an exponential. I know it's an exponential decay. I know it crosses at 3. Cross at 3, exponential decay. This one is correct. This one, this one, this one's exponential growth. Boom. Yes, you're absolutely right for B. That just changes, right? But we're not talking about those types of quadratic or exponentials this week, so you don't have to worry about them. All right, now exponential growth. Lots of things deal with exponential growth. There's a super simple formula for exponential growth. It is y is equal to a 1 plus r to the t power. A represents the original amount that you have. R represents the rate of growth. And T represents time. So here's our formula. Okay. Oh, yes. Yes, you would use, well, next week we get into more of the compounding interest kind of things. This is a very simplistic one for exponential growth. But stock markets, yeah, there's a lot of exponential growth there. So in this problem, it says the function f of x equals 500, 1.035 to the x power models the amount of money in a certificate of deposit after x years. How much money will there be in 6 years? Now, before I ask that question, how much money did they start with? What was the original amount of money put in? $500. This is the original amount that they put into, and this is 1 plus, and then 1 plus 0.035. So this is 3.5%. So this money certificate is making 3.5% interest. But now, how much would it be worth in 6 years? Well, now I just would plug in 6 here. So 500, 1.035 to the 6th power. Somebody with a calculator. I do have a calculator, so I could plug it in. All right, I've got a calculator, so I'm going to plug it in. So 500 times 1.035 raised to the 6th power. And I come up with $614.63. Make sure you take all of your answers to 2 decimal points this week. Why? Because we're dealing with money. Now, well, I suppose not all of them deal with money. But that is an exponential growth problem. Exponential decay, okay, very similar equation, okay, very similar, but guess what? It's a minus there. So it's going to be the original amount, 1 minus the rate to the t power. Now, I'm going to tell you one thing that you're going to get wrong this week on one of the problems. I'm going to give you a problem like this. I'm going to give you 5,000 times 0.95 to the x power. Okay? This is an exponential decay problem. And I'm going to ask you, what is the rate of decay? What is the rate of decay? How fast is this thing? 5%. You want to tell me how many people are going to put 95% down? So many people are going to say that this thing is decreasing at 95%. It's not. This is 1 minus r. Well, if you put 0.95 is equal to 1 minus r and you subtract 1 here, r is equal to 0.05 or 0.5%. Either one would be fine with me, but not 0.95. That would not be fine with me. So be careful on that problem when it asks you what the rate is. You have to, it's not the number inside there, okay? Most students mess up with that. Okay, so here's a problem. It says the population of a town is decreasing at a rate of 3% per year. In the year 2000, there were 1,700 people in that town. Write an exponential decay function to model the situation, then find the population in 2012. All right? So I'm going to let you guys work on this, and then we're going to go to our practice problems because I see the time is running, and we need to get those problems in. But Give me the equation for this right away. What is the equation? $1,700, because that's the original amount of people that were in the town. And then 0.97, because 1 minus 0.3 is 0.97. I agree with that 100% to the X bar. I love it. Now, Allison, why did you put 12 in there? Because the equation is this, okay? So if I ask you to find the equation, you better give me this. But if I asked you to find the population, I love what you put down, 0.97. Why did you put 12 down there? And why didn't you put 2012 in there? There's my question. Why 12 and not 2012? Because it said find the population in 2012. Ah, there you go. It tells us that in 2000, there were 1,700 people here. So my equation is written in the year 2000, okay? So that is where it starts, because they told us there were 1,700 people in the year 2000. So what is the population in 2012? Well, that's only 12 years away. So that's why Allison put down 12 there. Okay, that is, I always have kids, they'll put 2012 in for X, and it's like, man, your answer is going to be so far off, because when you start doing exponents and you put a huge number like that in there, it really messes the problem up. Okay, so, and I didn't solve it. So how many people are in that town after? Okay, so 3% in 12 years, I would say that there's probably going to be 1,600 people. Did somebody work that out? What did you get? 1,179? 12 years? 12 years? Could be, yeah. Okay. But this one I would not put 0.53 on. I wouldn't put a decimal on this problem. And the reason I wouldn't is because you can't have a 0.53 of a person. So money, yes, 2 decimal points. People, nah, I think I'd probably round it. All right. So here is the decimals presentation for this week. Okay. Let me, I'm going to share my screen with you guys here so we can all see the same problems at the same time. And I think you guys are going to have an easy time with this week's practice. I didn't get an email last night saying any of my answers were wrong. So I'm thinking they're all good. So I'm kind of excited. Because usually I get an email on Saturday or Sunday saying, Mr. Jenkins, I don't get how to do this problem. Okay. So problem number 1. I think we did this one already, right? What did we say the answer was for problem number 1? Letter D, right? Because it's an exponential decay function, so it's going down. So letter D is the correct answer for problem number 1. All right, pretty easy. Wow. They got to get tougher, don't they? Sure they do. Here's one. Determine whether the equation could represent exponential growth or exponential decay. Oh, that's a tough problem. Exponential growth. Oh, Samantha. Right, it's gonna be growth. And why is it growth? Now I know why some people would say decay, because they'd see this 1/3, but it's this number that the exponent is to that tells us if it's exponential growth or decay. The 1/3 is where you're starting from. This number is called the base, and that tells us if it's growth or decay. It's greater than 1, it is growth. Okay, so that one should be growth. So we're going to look at the base for those. I know how to get kids to make the wrong answers. Yes. All right, number 3. This one you have to work out. I'm going to take attendance while you guys are working this one out. Obviously, it's increasing, so this is exponential decay. Or I'm sorry, it's exponential growth. So your equation is going to be y is equal to the original price or value, and then 1 plus r to the t power. So I'll give you the equation, and then I want you guys to work it out, and then I'm going to take attendance as you do. All right, so you guys work it out. I'm taking attendance. Okay, attendance is taken. I just take a snapshot of who's here, and then I put it into a Google document afterwards. Now, for those of you that have never been here, attendance doesn't make a difference. The only reason I take attendance is because, you know, some people at the end of the semester, they'll say, why am I failing the class? And then I go back and look at attendance, and usually they've never come to anything, and it's like, okay, I understand why you're not passing. You don't come to the main lessons, you don't come to the help sessions, you don't do your work. Kind of adds up to why you're not passing the class. All right, so in this problem, what is my answer? What is the answer for this problem? Letter C? Oh, everybody says letter C. I didn't do the problem yet. So if I was going to do this problem, it says original value of sculpture, $950. So that's my original amount. The value is increasing, so I'm going to go 1 plus 0.15 each year. Find the value of the sculpture in 8 years. So this is a function that I would set up. Pretty easy to write an equation. So I'm going to work it out, 950. I don't know why I'm working out, because you guys, I'm sure, have it right. 1 plus, or times 1.15 raised to the 8th power, and I come up with $2,906.07. So I'm going to go with it. I'm going to agree with you guys. Letter C is the correct answer. All right. Number 4. Let's see what number 4 has in store for us. Oh, what type of graph is that? If you take a look at the graph, just looking at the graph, what type of graph is that? Decay. Right. So this is a decay problem, I would think. It says a bicycle depreciates at a rate of 15%. Teresa bought a bicycle for $250. How much should it be worth in 6 years? Okay. Can somebody write an equation for me? Okay. It's depreciating. Started off at $250. What is my equation that I should be using? Okay, I like both of your guys. Now, if I asked just for an equation, you should have the x in there. If you're going to solve it, yes, you're going to put the 6 in there because you're going to solve. I agree. So in this problem, first thing I do is I always look at the original amount. So it's 250. It's decreasing, so it's 1 minus 0.15 to the t power. So 1 minus point, and I don't even have to subtract this, but I don't want to. It doesn't make any difference. So that's 0.85 to the t power. 6 years later, put 6 in there. How much is that bicycle worth in 6 years? I don't know. A bicycle's not going to be worth that much in 6 years, is it? So $94, I could go with that. I mean, when you take a look at cars, a car depreciates at between 10 and 25% a year. Okay, so here's a question for you guys. Will that bicycle ever be worth 0 if we use this equation? No, because remember, an exponential function, it's going to go down, it's going to get very close to 0, but it will never hit 0. So the bike will never be worth 0. I would agree with that, the cap is probably higher because you can always sell it for something. Exactly. And then if you, and this is where kids always drive me crazy. And then they'll say, but Mr. Shanklin, after a while, that bike is going to gain value because it's going to be antique, so the value is going to start going up. It's like, oh, come on, guys. We don't want to think that hard in math. Yes. So, you know, the graph could go down, but it could go back up. Same thing with cars. I mean, if you take a look at some cars, I mean, some of these old cars, these antique cars, man, they get hundreds of thousands of dollars for them. So, you know, you take a really good care of your car, or you do it. You know, trading cards too. Yeah, all that stuff. It's going to go down, and then it's going to go back up. All right, problem number 5. It says the value y of a $15,000 investment over X years is represented by the equation 15,000 1.2 X over 3. What is the profit on a 6-year investment? Now, we're going to be spending more time with these types of problems next week, but remember, it's asking for what is the profit. So you've invested $1,500. You've got to subtract that off at the end, because profit means how much did you make from that $15,000. So we're going to use the equation to find the value after 6 years, and then we're going to subtract it off from 15,000. Okay. Uh-oh, the exponent is a fraction. So the total was 21,600, and then you subtracted it from 1,500. Okay. So this one was kind of a, you got to really read it carefully, but so I have y is equal to $15,000 times 1.2 to the x over 3. Okay. So somebody said that when you plugged it in, I have to go back. When you plugged it in, you get $21,600. Okay. So $21,600. But that's how much you would have at the end of 6 years. Okay. So how much did you make off of your investment? Well, I just took 15,000 and subtracted it from there, and that leaves you with $6,600. Okay, so that was, and we're going to be talking a little bit more about that next week. We're going to be talking about compound interest and stuff like that. I think that's what next week is about. Not 100% sure. I have like 3 different classes that are all working on exponents and logs and stuff, and it's like, okay, which class is doing what? All right. So number 6. Uh-oh. It says the New York Volleyball Association invited 64 teams to compete in a tournament. After each round, half of the teams were eliminated. Which equation represents the number of teams that remained in the tournament after our number of rounds? All right. That's kind of an interesting problem. So what we're trying to do is we're trying to write an equation for this thing. Okay. What is the, and I always start off with, what is the original amount? Okay, so in this problem, what's the original amount? 4, not 4, 64. There's 64 teams. And then it says after each round, half of the teams are eliminated. What is, if half are eliminated, what is my R value? What is the ratio? 0.5. That's what R is, because half of them are being eliminated. This is a, or you could go 1 minus 0.5. This is a exponential decay problem. So if I was going to write an equation for this thing, the first thing I start thinking about is, okay, where do I start? I started with 64 teams. What is the ratio? Well, it's going down, so it's going to be I could put 1/2 here to the t power. Okay, and it said, which equation represents the number of teams, t, that remain in the tournament after r rounds? Well, I should have used r here because that's the number of rounds. So my answer should be number 4, right? No, is that okay? That's why you put 4. Okay, or D. I didn't understand what some people were putting /D. That I get it now. It's number 4. I'm not sure on the practice if I have numbers or letters there. Is anybody in the practice? Is there numbers? Numbers? Okay, so you should pick number 4. All right. Seems like a pretty easy practice this week, doesn't it? Number 7. The number of members in a labor union is 240, and the number increases by 5% each year. Find the number of members after 4 years. Summative is not that hard. The first problem is asking you to, I think it is to graph, okay, or maybe write an equation for each graph, and then the next one is asking you to graph 2 problems, and then the rest of them are just problems like this, where it just gives you an equation, and you have to just write an equation and solve. That's it. That's the whole assessment this week. All right, so what is my equation here for this problem? It says the number of members in a labor union is 240. The number increases by 5% each year. Find the number of members after 4 years. Yeah, and that, but if I agree that a lot of these you can just put that right into your calculator. You're absolutely correct. So in this problem, I would say that my equation, but it does ask you, I think it does ask you to, it has a couple steps. It'll say, it'll ask you what is the equation, if this is the number of years, what would the price be? Okay, so if I did this problem, it's 240 and then 1 plus 0.05 to the 4. So 240, 1.05 to the 4th power. And my answer is 292 or B. All right. I agree with you guys. Now, a lot of people, they say, oh, I hate word problems, but these are pretty fun, aren't they? I mean, they're not hard. It's just you gotta find out the original amount. You have to know the rate that it's increasing or decreasing, and then you have to know the number of years. I still don't like word problems. Come on, man, give me a bone here. All right, number 8. It says the function f of x equals 10 times 2 to the x power models an insect population after x weeks. So how many insects were there at the beginning? 10. How fast is the population increasing? Because this is all things you should be able to tell just by looking at the equation. Okay, so it's doubling, isn't it? It's really doubling every 2 weeks. Or inside, what will the population be after 4 weeks? Okay, so what is my population after 4 weeks? So in this problem, all I had to do is put 4 in there. I didn't even have to ask you any of the other questions. I was just trying to see how much you guys understood about it. But all you had to do is plug 4 in there. We might have. I don't remember the lesson tutorial. The lesson tutorials, I did a lot of those over our winter break. I tried to get ahead of myself. I'm like on week 9, so I did all those. So there were, I tried to get ahead. That way, during the week, I can spend most of my time just correcting assessments and answering emails. All right, problem number 9. Which function represents exponential decay? Which one represents exponential decay? Number 3? I disagree. I don't agree with number 3. And the reason I don't, okay, what does a negative exponent do to a problem? It flips it over, doesn't it? So if I gave you 1/2 to the negative 2 power, isn't that the same thing as 2 over 1 to the 2nd power? So this, if I rewrote this problem, this is how it would be written. If I rewrote this problem, it would be written like this. Oh, Mr. Shanklin, you're getting way too tricky on us. What's my answer to this problem? It's number 4, isn't it? Okay. So that was kind of a tricky question there, having those negative exponents in there. But you got to be careful. You have to be careful. I will try to trick you on some of these. All right. Number 10, the last question on our practice. It says, which statement is true about the graph of 1/8 to the x power? The graph is always increasing. The graph is always decreasing. The graph passes through 1, 0. The graph has an asymptote x equals 0. Which one is true? Number 2, the graph is always decreasing. This is an exponential decay problem. Exponential decay means that that graph is going to go down, and it's going to keep going down, 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 down. It is always decreasing. That's exponential decay. Exponential growth That function is always increasing. It's always going up. That is the difference between exponential growth and exponential decay. Number 3, 1, 0. Let me show you where 1, 0 is. 1, 0 is right here. Does it cross there? Yeah. If they would have said 0, 1, I would have said okay. Now, x equals 0 is an asymptote. What is an asymptote? An asymptote is a vertical line that breaks the graph. So this is a vertical asymptote. Now, if they would have said the graph has a horizontal asymptote at y is equal to 0, I would have said yes. But x equals 0 means it goes this way. Y is equal to 0 means it goes this way. So it was kind of tricky there. Yeah, x equals 0 is going to be a vertical line. Y is equal to 0. If they would have put y is equal to 0, I would have said, yeah, that is also true. But it was x equals, so that is a vertical line. So it would not be equal to that. So number 2 is the correct answer there for that problem. Ladies and gentlemen, that is it for today. I think you're going to have an easy time with this week's assessment. I don't think it's compared to last week was a tough one. There is no question about it. This week, I think it's a nice one. It's, you have to be able to write an equation of a graph. You have to be able to graph it, and then you have to be able to do a bunch of word problems. Nap time? All right. You guys have a great week. I hope to see you back next week. Same place, same time for week number 6. Bye.